Do you know how did a software engineer get shot by the police? As usual, he ignored all the warnings. Today we have a practice topic, so this is not to deepen your theoretical knowledge in software evolution, but this is just to help you a little bit to get started on the project here. So the project will be built in a compiler, so obviously you need some crash course in compiler construction. I assume that you have some knowledge about how to construct a compiler. If not, get one of these books. There are many more books on compiler construction. These are just books that I either own or have read at some point. Some of them are better than others. It's not my intention to provide a complete overview of those or to advise some book or to retell you everything that is in those books. If you're interested in compilers, then please read some of those, preferably something newer. This is just to summarize some of the knowledge that might be dreaming somewhere inside you, might be sleeping somewhere in there, but is not necessarily immediately open for your project. So people say compilers, right? A compiler in a narrow sense is a very specific type of a language processor. And that's the one that takes text of your program, usually written in some high-level programming language, and as the output of that, it produces code. It can be machine code, virtual machine code, real machine code, but usually something very low level that is then executable. It could be an exe, a DLL, a jar, anything, .class, anything that is executable somewhere. You can also have an interpreter. An interpreter does something slightly different. So it starts as a compiler, it takes a text, probably in some high-level language, and then it does stuff with it. We'll have a look inside in a moment. But then it does not generate code. It immediately computes all the things that are there and does all the stuff that are needed to be interpreted, and then it produces the result to you. You may also encounter the word parser, and parser can be viewed as a separate language processor or as a part of a compiler or interpreter as a pipeline in that. So what does a parser do? It takes the text and produces some model of it, some understanding of it. Quite often it takes the form of a tree, or at least it pretends to be a tree, because trees are comfortable data structures to work with. You can also have the opposite, the unparser, sometimes called a formatter or pretty printer, where you already have a model, you already have a tree, and then you produce a text out of it. So quite often the classical use for that was that you have a tree and you want some nice representation of it that is better readable than just some memory layout of that tree. So then you print it so that it's pretty, and that's why it's called a pretty printer. You can also have a preprocessor. If you've worked with languages such as C++, they definitely rely on preprocessor all the time. Some languages rely on that much less or don't have a preprocessor at all. But a preprocessor is basically a text-to-text interpreter of some language with macros, with expansions, with where you can connect like different files and include them there. You can have some conditions there, and you can check whether you are being compiled, for instance, on Linux or Windows, and then you can rely on different libraries and so forth. So that's what a preprocessor does. A translator, transformer, or transformation tool, or in some cases it can be a refactoring tool, for instance. That's a model-to-model transformation, right? So you already have, let's say, a tree or some kind of representation of your program, and then you produce another tree or another model, right? With different purposes. There can be many of those. You can also have an analyzer, which is a tool that takes a model and computes some property on it. So it can be something that calculates the number of lines of code, or calculates how complex your code is, or takes multiple artifacts like your tests and your program and calculates what is the coverage that those tests provide on this particular code. Right? That's some property, and usually it's some number, maybe a bunch of numbers, but it condenses that model to this property. And finally, you can have generators, which where you have a text or you have some model, it doesn't matter, and then you generate some artifact out of it. So if it's a part of a compiler, then usually it takes a tree or some intermediate representation of your program, and then it generates an executable code. But it can be a generator of also some piece of text, because some languages do that. While you're programming, you can generate parts of the program that you are still programming in. It's called staging or morphing, and there can, just Google up metaprogramming or ask me in one of our sessions and we'll go deeper into that. So there are many more kinds of language processor, but this is the sort of basic vocabulary that you should have in order to comfortably to proceed there. Compilation pipeline. In general, there are thousands of variations of this, but in general, you go from something that represents your source code. I was calling it text in all the previous slides. So the source code, the original thing that you write and then you put into your compiler or your language processor. Then at some point you get what I was calling a model. Quite often it's called a parse tree, so I put it here as a parse tree. Quite often it's not a tree at all, but the terminology is very reluctant to change. And then from that you get some intermediate representation. It could also still be a tree. It could still be that parse tree with some extra annotations and different things, but it could be a different intermediate representation. And then eventually you produce machine code. The first part that goes from the source code to a parse tree, that is sometimes called a front end. It usually contains a parser. It may or may not contain a grammar. A grammar is a specification for the parser on how to work with the source code. It's a structural commitment to what things can you expect in this source code and where should they end up in a tree. And sometimes this is also called syntactic analysis or syntax analysis. What happens in the middle, where you already have some model and you want to put more stuff in it, this is called static checking, quite often type checking, because types are important in programming. It can be called semantic analysis because you are not busy with the syntax anymore, you are busy with semantics. You are trying to understand what this tree and what this model represents in order to enrich the representation of it. And sometimes it's also entails desugaring, and desugaring is when you have some constructs that sort of exist on a syntax level, in the sense that programmers can write it that way, but they don't map to new concepts. It's just a, let's say, shorter way to write certain things. So then you remove that sugar, because you don't need that much sugar in your life really, and then you decompose it into a representation in some basic constructs that exist elsewhere. And finally, the last part, that's usually it's called code generation or code generator, the thing that does the code generation. It may or may not include an arbitrary number of optimizations, sometimes a lot and sometimes none at all. And sometimes this is called the backend. And the middle part, sometimes people call it the mid-end or middle end, but I mean, yeah, I'm always confused because it's not an end, right? It's in the middle. This is the basic terminology for the compilation pipeline, and in general the things that need to happen when you progress down the line. The top choices for this course that you can have, and if you have some other ideas, please discuss with me. This is very open. But the top choice number one is just build a full compiler, right? So you need to go from text to model to intermediate representation to code. This is very challenging, and it requires a lot of effort. But the architecture is known. You pretty much, even if you have no idea at all, you pick up a book, you read how to make a compiler, and you follow the book exactly, and then you have the compiler. And there are a lot of very good frameworks that are available. For instance, LLVM is a framework that literally gives you already a very good intermediate representation. It gives you a good backend or bunch of backends actually to generate code from that intermediate representation. So the only thing that you need to do is to write a good front end and then keep writing good transformations that enrich the intermediate representation and desugar it and whatnot. And well, that's quite comfortable to do because they have very mature API and very nice documentation and so forth. You can also have some language workbenches like Rascal or SpoofX, which are big things, big frameworks that allow you to build entire things from just little specifications, and they generate plugins, they incorporate that into your interactive development environments and so forth. Another good thing about building a full compiler, it's pretty much guaranteed that all the features of Baby COBOL that you can get experience points for, they are open for the full compiler. This is guaranteed. Another very good choice for this course is to build an interpreter. Right? You don't need them to be busy with the code generation. You need to just execute it right away. In difficulty, this is pretty much comparable. You still get a lot of support. So language workbenches is still there for you. They give a lot of stuff. You probably won't profit from things like LLVM that much, but you can profit from a lot of things like Antler, which is a parser generator. So it gives you a tree if you give it a grammar and the input to the parser. Right? So instead of writing the parser manually, you can write a grammar, and it's highly recommended to write just a grammar, then use a good tool like Antler or any other generator if you fancy a different one. And then you have your front end pretty much already up to you. And after that, you are in your language. And in this course, you choose your own language, so it doesn't matter for me. And then you are in your comfort zone, which is good. Some features, probably all features will still be possible to get experience points for, but some of them will be slightly easier, some of them will be slightly harder, but you will find out. And the third of the top choices for this course is to build a REPL. So this is a read, eval, print loop, also known as the shell. So it's a sort of an interpreter, but it's slightly more fun. It's still comparable in difficulty. The architecture, again, is known as with the other two choices. It's an interactive thing. So it's something, if you worked with an interpreter of Python, right, you can have the mode where you say Python and then the name of the program, and then it works as an interpreter. So it takes it and then interprets exactly what it does. Or you can just say Python and then you have the REPL. Right? And then you can experiment with the language, you can play interactively with it, and this is live, this is interactive, so this can be more fun. But some features might be easier and some features might be impossible, or at least very non-trivial on how exactly would you do it with REPL. But you can still have a lot of fun, and because you're having fun, you may have more progress on all the other features that are easier. So all three options are very decent and they are solid, and you can go for any of those without any problem. I'm just saying that these three are probably the best for you to choose one of those. If you have any other ideas, you know where to find me. To conclude this, language processors, they are also sometimes called grammarware because many of those are pieces of software that are related to or inferred to from a grammar or some other comparable specification. The pipeline goes as follows. You have the text and then you use a parser to get some model, some tree out of that text. Then you use some analyzer to enrich that model, enrich that tree representation. You get some intermediate representation. And once you are happy with it, you use the generator to produce the code for the things that were specified in the original source code. In this course, you will learn compiler construction for real. So you will hone your skills, whatever skills you have in compiler construction, little or much, I don't care. But you will use all of them and you will hone them for real problems that exist for in the world of legacy. I propose that you make a choice between making a compiler, making an interpreter, or making a REPL, making a shell for your language. And whatever you choose, it's up to you. If you have any questions or you want to discuss, you know where to find me. And in the meantime, don't ignore the warnings and keep the evolution going.